Hi there, this is Denise again, wanting to talk to you about threads, executors, and runnables for the 360 class. So what are threads? Our operating system nowadays can perform multiple processes concurrently. Before, computers with multiple core processors, generally programs used to run sequentially. Possibly with some time slicing and such, that probably would have been the other way that would have happened. But from top to bottom, they would have run sequentially. And so today, we have so much more capacity and control now. In your Java programs, we can run portions of our code concurrently as well. So we do this using threads. Okay, so let me give you an example. Let's take laundry. There are multiple steps to doing laundry. First, you have to sort it into colors, whites and towels, etc. And then you have to look for spots and apply stain remover on the spots. And then you have to load it into the washer and put laundry soap and then run the machine. And then you have to dry the clothes or hang them on the line. Then you have to fold them or put them on hangers. So in this laundry scenario, if a person were to do it all by themselves, step by step, sequentially, it takes a really long time to do laundry. So if I could employ a few more people to help out or to do different tasks at the same time, it would take much less time. So I would assign one thread to sorting the dirty laundry. Then I would assign another thread to checking for stains and applying the stain remover. And then another thread would be folding clothes. This is the kind of processing that lends itself to having one big process, but dividing it into smaller tasks. And then we can employ our threads to do different tasks at the same time, thereby finishing the work faster. And really, that's the whole point of threads. So there's various ways to use a thread API. You can extend the class to create a thread, but since it is an inheritance relationship, you can only extend one class at a time. So that can be very limiting. You can also create a thread using a runnable implementation. This is the preferred method because you can create many threads using the runnable on whatever class it's implemented on. So you could have it on multiple different classes having different kinds of code inside of it, and you could be running multiple threads on that. I got some information, I saw some comments off of the internet, and I liked what this one person said. He said, you should definitely stick with implementing the runnable. By choosing to extend the extension thread way, you're creating a class hierarchy that is probably nonsensical and will wind up restricting your options for refactoring and things in the future. By choosing to implement runnable, you make no demands on whatever lineage or the implementer is, and so you can use the powerful abstractions like the executor service to abstract away the nuts and bolts of running a chunk of code. So, and then finally he said, finally, preferring to implement an interface rather than to an extended class is always a good practice. So I thought that was very good. Okay. So running a class in separate threads you need a thread object class, you need a runnable interface, and then you need to invoke the start method for sure. Okay, preventing race conditions. A race condition occurs when two or more threads are trying to read and write to a shared variable at the same time, okay? And so that causes, well, let's look down here in this part right here where there's interleaving instructions, okay? So say thread 1 has, a counter that they have to read and then add 1, 2, and then they have to write it back out. And because that's what happens to counters. That's what you do. You basically have to do that. And then thread 2 is trying to do the same thing, but they're using the same counter here, you see. So thread 1 got it right at first, but then thread 2 tries to read the value, and it thinks, hey, it's really 2, or it's really 1 or something. There's because the because Java is in control of how these things get run, they can actually cause interleaving instructions. And so a race condition is when these two threads are on the same, working on the same variable, but one is grabbing it at a different point and processing different instructions on it at a different time. And as a result, you wind up having it not updated properly. And and that's basically it. There's better ways to explain this. I have seen better ways out there, and I'm sorry, but that's what it. Hopefully, that made some sense. So, a visibility problem is when variables are accessed by more than one thread, and the variable can be changed in one thread without the other one knowing. So let's look at this picture right here. Okay, so thread 1 gets a copy of the variable, same variable, and puts it in its local cache for this thread, and this guy thread 2 does the same thing. Well, thread 1 gets done first, and he wants to change it to. He changes it to false, but thread 2 it hasn't done with it, and so he thought it was true, but now it's saying it's false, or he's still thinking it's true, and so you can actually have infinite processes running infinitely because these things are, the visibility isn't seen. You can solve this problem quite easily by using volatile, and volatile causes that this, whenever there's a change to it, gets pushed down to the shared class, and then it's shared between all the threads that were using the same copy of it. Okay, so common use, I found this little chart like this. Common uses of volatile are on flags, and then atomic integer and atomic long are on counters, and atomic reference on caches and such. So I thought that was a good little piece of information there. Okay, so the executor is like a manager, and it's the preferred method for managing threads. And there's executor and executor service. They're all part of the same framework, or they extend each other's frameworks, I believe, and then you submit a task to the executor, and it goes into a task queue or pool. And so you have to, so it's basically managing it. And so there's many different methods out there. You can have the fixed pool if you'd want, and you could say, hey, I only want like 3 threads out there, or 6 threads, or whatever. And the executor service will, if you had more, say you had 3 threads that you created, or you said you could have a fixed pool of 3 threads, then, and you had 12 tasks, the executor service would have the other ones waiting in a queue until the thread pool was opened, and it would process them in it, basically a queue. So it manages all of it, and it's quite, it makes life a lot easier. You do have to remember to shut down the executor service. If you don't, you can cause problems, especially if you close your program, I think. And once it is closed, if you try to start up another thread afterward, you'll definitely get an exception error as well. I've seen that too. So let me show you some of my code really quick. Here's my code. I actually have 2 projects practically named the same thing, because this project, when I started out, things weren't going well, and so I changed it completely. Well, I mean, I had the same ideas, of course, but I changed the way I was doing things because I got smarter as I went. So this is pretty easy stuff. Okay, I like it pretty simple, because I think the clearer it is, the better off you are. But so I have examples of the threads just using extends, and then I have the examples of threads using the runnable. I have a bunch of comments here. Please ignore that. And then here is the example of the executor services in a couple different ways. Okay, so in this, okay, here we go. This is the simplest way right here, with the threads just being extended. Okay, so or just the threads running the threads. So I'm creating, running the thread extends. I start it, and then it's going to print out first spawn thread from extends. Okay, and then it's going to do the same thing for 2. Okay, so let's look at thread extends. Basically, all this is it's thread extends thread. Thread extends thread. Okay, and so it's running the threads with the extends relationship or the inheritance relationship, and I'm using the atomic integers here, and just running, doing a for loop 10 through 1 basically, and I'm just having the ID printout, and I'm decrementing it here. There is an increment, there's a decrement, there's a lot of different methods that you can use, and it just runs and runs until it gets that done. And so then we go back and I just run a second one of them, just try and be able to show that I can run two threads or 2 or 3 or whatever, how many of threads I wanted. I could just initialize them like that. Or get them going like that. So the example of threads using the runnable, let's see. So here I'm calling do task. Okay, and the reason why I can't use this one anywhere is because this one is extend, so I have to use a different class because I'm implementing runnable in this case. Okay, this is the preferred way to do it. And I basically just start that, and I start the task in the thread for thread 1, and it prints out using I'm spawning a new thread using the runnable, and second spawned runnable. So I'm just doing it a couple of times. And so let's just look at do task really fast here. And so basically the only thing that really is different is I'm implementing the runnable, and I'm doing the same thing here. Let's see, I put in here because it was kind of getting a little boring to use the sleep for 500 because it just made it too consistent. So I thought, okay, well, we'll try this math random sleep in here and see if it changes anything. It did a little bit. It did. So, and let's go back here. All right, so the example of the executor. So in this one, I have 2 executors. I have example 1 and example 2, and I'll show you the difference, okay? This one actually is, this first executor service is running the fixed thread pool, and that was recommended for newbies so that we don't blow things up. And then I wanted to try the callable. I wanted to try that because I thought that would be fun. So let's go over and look at executor example. Here we go. So the example 1, here we go. It's running the executor service, whatever, and then new fixed thread pool, and I put it to 3. Okay, I could have put it to more or less or whatever, but and I think I did play with that. I definitely did play with that, and then I just made it down to 3 is the last thing. So it just basically starts up my tasks, and then it shuts down, and it's so nice, and it's doing that same do task, the same thing. And what's so cool is you could just run this do task as many times as you wanted, because it's if you had something that was very much repeatable, you could just run it on for different threads and get that done. So the difference here, let's look at this one. The difference here is the callable situation. Okay, so here's a fixed pool of 5, although I'm only calling 3 tasks here. So this is using that lambda expression, which is kind of cool. Once you understand what it means, it's cool. So it's running the callable, and I'm telling you it's sleeping for 2,000 here, 1,000 here, and 5,000 here. Task 1, task 2, and task 3 get running, and then the return is I put in for each return, I just task 1, task 2, task 3, and this is from the future. Okay, so basically once these all get running, it will make an array of these messages, or task 1, task 2, and task 3, which are basically these strings here. And then I print out the result, and then I shut it down, and it comes back to this task master. And the last thing after it does that, it just says main thread assigned to Java is ending now. So let's run this, and I will show you how it will work. Let's make this a little bit bigger. And you can see how they're not all, they're running at different, you can see these ones are lined up pretty well, but it just depends on how the JVM wants to schedule these things, and how plus I did do the random math time sleep on the one, but for the some of them, they were just like sleep 1,000, sleep 2,000 or something like that. So anyways, it's this is my expected results. This is what I did expect, and I don't know what else I can point out here for you. But that is basically the code, and I wish I could have told you more, because there's so much to this, and I've learned so much. It was very exciting, and I was not the teacher this week. It was for this topic. It was Tammy, and she did a wonderful job, and it was kind of overwhelming until you actually consume the information, and then you're able to understand what you're supposed to do and such. So this was really very fun, and I wish you guys all the best.